some of the knowledge and also the elements that we learn in our second lecture, we all actually can use in our third lecture. Okay. Yes, the number is 200 students, so I think I can start. Okay, so this is the situation of the projectile motions. Okay, basically, it's involve the maximum, or we call h. Okay, the maximum height we call h, and also it's involved the maximum of distance, or r. Okay, and then it's moved like this lah. Okay, it's moved like this, and then when I freeze these motions, I be like this lah. Okay, so you have the velocity, for example, initial velocity. This is general. Initial velocity is general, but you also have the velocity at the y directions and velocity at the x directions. Okay, velocity at the vertical and then velocity at the horizontal. And then from this, we also have the h. H, as I mentioned, is the maximum or the highest peak that the object can be. Okay, and then at this higher speed, uy is equal to 0. Okay, u for y equal to 0. Velocity for y directions is equal to 0. And then we have the x velocity is constant. Okay, in any directions. Okay, x velocity is constant, and then you have the ay equal to negative g. This is the gravity acceleration for the gravity 9.81, just only for ay for the y directions. And then we also know ax is equal to 0 lah, because of x is not involved the gravity. And then if we look to the other situations, okay, we can see that we must focus to the two elements. Number one is the element at the green one. This is y directions. And then number two is the x direction at the red one. Okay, if we look to the green one, when it's upward, it starts to decrease. Okay, this is, for example, initial velocity, and then it's decrease and decrease, and then at the top is equal to 0 or it's disappear. Okay, and I think I already mentioned that in the freeform motions. So y is decreased because it needs to against the direction for the gravity, or the motion for the gravity. So that's why it start decrease, 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 and then it start increase, 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 but it's different direction lah. This is the y directions, and then at this side this is y direction, so the direction is different. This is positive, maybe it's negative. That for y. For x is constant, so we have the vx initial. This is cos lah. When we have the angle, we have the cos theta. The value will be remain the same. Okay, at the highest point and also at the end. Why? Okay, we will discuss after this. Okay, at least you know the situation of x direction and y direction. The y direction is changing. Okay, so either is increase or either is decrease, but for the x is constant. Okay, if we look, or we just focus at the y directions. Okay, it's focused for the y directions. So this, as I already mentioned, for example, we have the v initial, and then this is for y direction, v initial sine theta. So initial velocity, okay, for the vertical component is a v initial sine theta. Okay, acceleration is for y direction is negative g, and then displacement at time. Okay, displacement at sy. So sy any point lah. So it can be here. Okay, it can be here, or maybe it can be here. Okay, so sy, you use the equation, kinematics equations, as we learned before. Sy equal to v initial y t minus 1 over 2 gt square, because we know v initial y is v initial sine theta, so we must use v initial sine theta. So that's why we have the sy equal to v initial sine theta t minus 1 over 2 gt square. Okay, this is for displacement at time. Okay, so any point at this vertical motions. Number two is the velocity at time. So this is also the kinematic equations. You have the v final y equals to v initial y minus gt. Okay, this is equation for the kinematics. That's why we have the v final y equals to v initial sine theta minus gt. Basically, final y ni kat sini lah lebih kurang. Okay, because basically the question needs you to calculate the final velocity y before it's reach the ground. For example, at this point. Okay, before it's reach the ground. So kalau dah reach ground ni, kita dah tahu lah v equal to 0. Okay, v equal to 0 because it stop when it's reached the ground. But basically the question needs you to calculate before it reach the ground. Basically in this lah. So we can have the different sign. So for example, y is like this. So that's why we can have the y is negative. So it can be v final y. It can be negative lah because it's in different directions. Okay, so that's it for y components. And then we look to the x components. Okay, so kejap, tertinggal. For the y component or directions, you also can calculate the highest point or the h. Use these equations. Okay, boleh guna these equations. Okay, so in this equation you do not need to use the kinematic equations. Tak payah nak guna equation kinematics. Okay, you direct terus menggunakan this h. Dia dah rearrange kat situ. So dia just boleh membantulah. So is dua-dua betul. Okay, you can use this equation, you can use the kinematic equation. So in the exercise nanti saya akan tunjuk dia punya persamaan dia. Okay, untuk x direction pun sama. Okay, as we look initial velocity, dia akan jadi v initial x lah. So and then this is cos. Okay, I think you know cos and sin. Okay, sebelahan per hypotenuse and then setentang per hypotenuse. That's common thing lah. I think you learn in school. Okay, so Vix is Vi cos theta and then acceleration Ax equal to 0 because it's not involved the gravity. So this Ax equal to 0. And then the placement dia akan jadi Sx equal to V initial x t sahaja. Okay, without minus half a t square. Asal dia dia punya equation dia kan. Tapi because of a ni equal to 0, that's why yang belakang tu dia dah tak ada. So that's why just only Sx initial x t. Okay, and then for the final sama juga. So the equation supposed to v final x equals to v initial x minus at. Okay, itu equation yang asal. Tapi because of a equal to 0, it cancel out. So that's why dia just tinggal v final x equals to v initial x. So ini sebenarnya proof that I say that the motion of x direction is constant. Okay, the final x, okay, the velocity final for the x equals to the velocity initial. So that's why we look for this figure. X is constant. Okay, either it's initial or either it's final or any point on the projectile motions. Okay, so that equation actually prove that the velocity at the x is constant. Okay, it's depend on the initial velocity. Okay, and then when I compare this, okay, bila kita compare mungkin senang kita nak lihat dan mungkin kita nak hafal lah. Okay, this is vertical and then this is horizontal. For vertical is sine theta, and then for horizontal cos theta, and then for vertical is negative g for a, but for horizontal a equal to 0. And then the displacement, okay, supposed to have the same equations, okay, v initial t minus half gt square, but for the vertical or for the horizontal, because of g is not involved the g, that's why I just left v initial xt. And then sama juga for the vertical at time. So we just have a v final x equal to v initial x. Okay. And then as we know, v initial x is a v initial cos theta. Okay. Ini untuk dia punya vertical. So when you have the equations, need to calculate the velocity. Okay. The velocity. For example, final velocity. You need to calculate the final velocity. So when you have the final velocity, it's actually combination between v final, okay, for y, and also v final for x. Okay, so for example, the question need you to calculate the velocity final. For example, here lah, v final kat sini. Okay, so you need to calculate v final untuk y dan juga v final untuk x. So mana equation dia? Yang ni lah. Kalau v final untuk x, yang ni. V final untuk y, yang ni. Okay, yang ni lah, yang ni je. Okay, so that's why from this to calculate the velocity is you combine v final x and also v final y, and then v final x square plus v final y square, and then you square root, and then you have the v. Okay, this is a v final. And then because of its vector, okay, you need to calculate the directions. Okay, the direction here we consider as an angle. Okay, angle. So my inverse tan v final y over v final x. Okay, dikira as angle. Okay, so kalau kita lihat is tan inverse lah, tan inverse kat sini. So that's why when you have the v, for example 50 meter per second square, and then what is the direction, 50 degree or 30 degree. Okay, and this also we will discuss in exercise nanti. Okay, boleh kot kan, dekat chatbot tak ada soalan pun. Okay, so Yes, thank you. This is ayat 1 kan. Last kelas kot. Kelas akhir ni semua faham, senang nak habis kan. Okay, so we look to the exercise or simple example. Okay, it's quite simple lah, just straightforward. The questions, making an angle 50 degree with the horizontal, a cannon fire a ball with a muzzle speed of 100 meter per second. 1R is initial velocity and horizontal speed. Initial velocity and horizontal. So you just gonna either cos or either tan lah. Sorry, either cos or either sine. And what is its peak altitude? Peak altitude is the maximum height. Okay, maximum height. So his h tadi lah. And then on the way up, how long will it take to reach altitude 100 meter? So this is time. Okay, what is the time that is used to before it's reached the maximum point? Okay, ini quite simple. For example, this is the cannon tu lah. So that's why we have the 50 degree there, and then we have the 100 meter per second. That is initial. So the question, what R is initial vertical? So you gunalah Vy untuk initial, you use sine, and then Vx untuk initial, we use cos. Okay, so you have the 76.6 meter per second for Y directions, and for X direction 64.2 meter per second. And what is its peak altitude? Ini kita tahu tadi, at the peak altitude or at the highest point, Vy is equal to 0. Ini kena tahu. Okay, kenapa dia equal to 0? Saya dah cerita tadi. Dia start with the initial and then it's decrease. At the highest point, it's disappear. That's why Vy is equal to 0. And then it's increase again, but in the different directions. Itu kita lihat tadi dalam figure. Okay, so we have the Vy equal to 0, and then we have the Vx is constant. Okay, kita dah tahu 64.2. So any point x, either here or either here, or either here, dia akan dapat nilai yang sama untuk x because it's constant. Okay, and from this we can use these equations. Okay, yang mana yang tidak melibatkan time. Okay, kalau kita nak guna equation s equals to v initial t itu is cannot be used lah because kita do not have the information of time. So we can have this equation. So we have the Vy equal to 0. So we just put down in the equation. So 0 equal to 76.6 equals to 2g h. Okay, so that's why we have h equals to 299 meter. So that's why I said if you want to use these equations, we will get the same answer. Okay, v initial square sine square theta over 2g. G here is just 9.81 lah. Dia bila guna this equation, dia tak melibatkan positif negatif. Okay, you just put the value. Okay, you akan dapat nilai yang asal juga 2.99 meter. Okay, so for example, the question also needs you to calculate the time. Okay, before it's reached to the maximum point, you also can use these equations. Okay, you can use this equation, v final equals to v initial y minus gt, and you know that v final is 0. So that's why you have the 0 equals to v initial 76.6 minus 9.81 t. So that's why you can calculate t. So in this case, so when I calculate, I got 3.9 seconds. Okay, so from this you can calculate the h or the maximum point, and you also can calculate the t. Okay, because when Vy equal to 0, so the questions much easier to solve. Okay, because we have the Vy equal to 0, so when we want to solve, tak payah nak pakai quadratic lah. Kalau you pakai nilai s pun sama juga. Okay, so you tak payah guna quadratic because Vy equal to 0. And then the last question is on the way up, how long will it take to reach an altitude 100 meter? Okay, so altitude 100 meter, because we know that the highest point is 299. So that's why, for example, 100 meter is here to the left, but it also can be to the right. Okay, it also can be to the right. Okay, tapi dia kat belah kanan ni dia punya nilai dia akan berubah lah. Okay, for example, because this is considered upward. Okay, and then this is considered downwards. Okay, kita dah belajar bila upward macam mana dia punya sign dia, downward macam mana dia punya sign dia. Okay, so that's why the good thing I think I use the upward because s will be positive. Okay, so when we have this, kita guna equation tu je lah, satu je untuk dapatkan nilai t. Okay, s equals to v initial t minus 1/2 g t square. Okay, because kita tak tahu v final. Okay, we cannot use v final equals to v initial minus at. Okay, nak dapatkan nilai t tu because kita tak tahu at 100 meter ni what is dia punya v final. Okay, since kita tahu dia punya maklumat tak cukup, so kita kena guna this equation lah, yang mana semua ada lah. So we have the S, we have initial velocity, and then we have G. Okay, but in this case, when I use this, okay, belah kiri dia, so this is upward. So my S is positive lah. Okay, my S is positive. And then I have the 76.6, and then it's minus 4.905 T square. Okay, but if you want to use this side, okay, the ball is start to going down or to downward. So that's why nilai S ni dia akan jadi negative sign. Okay, dia ada berbeza sikit lah. Nilai mungkin sama. So kita kena lihat nanti. Okay, tapi the T tu because this is quadratic kan. So T tu akan dapat dua nilai. So that's why it can be T here and it can be T here. Okay, ada dua nilai T tu. Okay, so ini tak ada masalah. You kena guna quadratic lah. So we have the 4.905 T square and then minus blah 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 lah. And then you have the A, you have B, you have C. Okay, please consider this negative because kadang-kadang kalau itu salah kat sini habis salah. Okay, because this is negative, so B is negative. You use the quadratics, and then you have the T equal to 1.43 seconds. Okay, so if you have the two value of T, okay, basically the highest one akan jadi belah sini lah. For example, I'm not sure what is another T. So saya tak ingat, saya tak letak kat sini. So if you have another T that higher this 1.43, I think this is 1.43 because if you look to the highest one, like as I tak ingat, as I calculate tadi saya tunjuk tadi kan 3.19 for the highest. Okay, kalau you still remember, kita dah kira for the highest is 3.19. So that's why 1.43 ni belah sini lah. So basically for this side you akan dapat lebih daripada 3 lah, maybe 4 seconds. Okay, so basically both is positive lah. So they have the 2.100 meter. This can be 100 meter, this is can be 100 meter because this is the symmetry. Okay, untuk parabola ni dia bentuk dia symmetry. Belah kiri sama dengan belah kanan. Okay, boleh? So saya tengok cikgu sekejap. They have question tadi. Mana tadi? Nilai doktor Vx nilai dia kekal ke? Vx ya constant, yalah kekal lah. So maknanya tapi it depend on angle lah. So that's why I said kalau initial dia 10. So that's why yang final dia akan jadi 10. Yes, kekal. Will V for x always be constant? V for x. Yalah tadilah kalau kita discuss tadi V for x. For example V tadi mana tadi? Hundreds. Okay, kita dah kira tadi kan. Saya patah balik ya. Ini 64.2 ni dia akan jadi constant lah. Idea dekat sini as I mentioned tadi. Dekat sini. Okay. So dia akan jadi constant. Ini apa nilai? Okay, itu je daripada checkbox. Okay. So I proceed to other exercise. Okay. We have other questions macam ni. Macam ni question ni dia dah separuh parabola. It's not fully parabola macam parabolic lah, macam your first question tadi. A youngster hurls the ball horizontally at a speed of 7 meter per second from the bridge 50 meter above a river. So dia dah kata dia ball tu memang dah ada ke atas. Okay, dah ada ke atas bridge tu. And then the question, how long will the ball take to hit the water? How long? It's time lah. And then B, what is the velocity of the ball just before it reach land? Okay, what is the velocity? Ini yang saya mention tadi. What is the velocity? So it's final velocity lah. Okay, before it's reach land ataupun it's reach the water ke? Ya sini ada water kat bawah tu, ada water lah. So before it's reach the water, that's mean the question need to calculate the final velocity. So you have the final velocity x, you have the final velocity y. So you need to combine to get the magnitude final velocity. And then how far from the bridge will it strike? So this is x, s untuk x. Okay, so bila kita lukis dia macam ni lah lebih kurang. Okay, the ball already on the top of the bridge. So dia as I said dia macam half of parabola. So supposed to have macam ni kan untuk penuh. Okay, so basically the first question is to calculate the T. Okay, to calculate the T, but we know the information from the questions as y is negative 50. Y is negative because of it start to downward. Okay, you have the parabolics as I mentioned. This is upward and then this is downwards. Okay, upward is considered as positive, downward S they consider as negative. Okay, so you have the S is negative 50 and then you have the V initial, sorry, V initial and also Vy lah. Because it start dekat sini dikira as V initial lah. Tapi kita tahu this is at the highest point. Okay, at the highest point Vy is equal to 0. Okay, so dia akan jadi V initial lah. And then we have the Vx equal to 7 meter per second because of dia dah dibagi kat sini Vx is equal to 7 meter per second. And then apa lagi dia bagi? Inilah this is nak dapatkan dia punya V final tadi. Okay, before it reach the ground or the water. And then this is the last question is Sx. Okay, Sx is to get the distance between the bridge and also the ball. Okay, so the first question is to calculate the T. Okay, so since we have the Vy equal to 0, that's why this will be cancelled out. Dia hanya tinggal is negative 50 is equal to minus is equal to 0 minus 4.905 T square. And then you have T, okay, 3.19 seconds. So this is the time that the ball take to reach the ground, okay, 3.19 seconds. That's the first questions. And then the second question is to calculate V final. Okay, V final. Okay, so the equation that we can use for V final is V final equals to V initial minus AT or minus GT. So we can use these equations. Okay, V final equal to V initial minus GT. And then for V final, we must consider X direction and also the Y direction. So for example, we want to look at the Y directions, X direction. This is the equation there yang asal. And then because of G equal to 0, because of X direction, as we know, do not involve the gravity. So we have the Vx final equals to Vx initial. Ini Y, this is Y. And this is Vx final is equals to Vy. Vx final, Vx initial. So that's why we know that Vx initial is 7. So that's why Vx final also we have the 7s. Okay, untuk verticals, we have these equations. Vy final equals to V initial minus GT. Ini kita ada maklumat dia. So we have the Vy final is 0 because this is the 0. So Vy initial is 0. And we have a negative 9.81 and 3.19. And then this is negative 31.29 because this is direction is different with the directions of the upwards. Okay, so that's why you have the negative sign 31.29. But this is not the answer because the answer needs your V final. So you need to combine this Vx final and then Vy finals, and then when you combine, we have the 32.06 meter per second. And then because it's vector, you need to calculate the directions. The direction in this case is the angle. So you have the inverse tan V final Y over V final X, and then you have this angle. So if the question needs you to sketch the V final, so you must base on this angle lah. For example 77, so it's supposed to mungkin macam ni lah, and this is 77. Okay, 77.39. Okay, so it's depend lah. So kadang-kadang mungkin dekat sini ke ataupun dekat sini ke, it's depend on the angle. Okay, boleh. And then the last questions. The last question is to calculate Sx, okay, the distance between the ball and also between the bridge, okay, the ball and also the bridge. So kita guna Sx. Kita tahu dia punya equation Sx dia is sama macam this equations, tapi is without this. Dia hanya tinggal Sx equals to Vxt, okay. So we have the Vx, kita dah tahu is 7. And then we have the T, we already calculate T, 3.19. So that's why we have the Sx, or the distance between the ball and also the bridge is 22.33 meter. Okay, so I think that's all. So I look the question for the chatbot first. Doctor, if we use the formula H, is the G value doesn't need to be negative? Yes, saya dah mention tadi dalam mana? Dalam masa lecture tadi. So if you use that direction, the equations, you don't need to consider it's positive and negative. We just use G equal to 9.81. Okay. So any questions lagi? Doctor, does the vertical of X horizontal component become 0 2 when it hit the ground? Yalah, bila dah berhenti, X direction, Y direction kosong lah. Yes. Okay. Doctor, macam mana dapat angle tu? Dah cerita dah tadi. You jangan tidur. Okay, because saya pun tak nampak. Saya tutup kamera, you pun tutup kamera. So saya tak tahu apa yang buat. Okay, kita dah mention tadi. Saya dah banyak kali mention. Dan dapat the angle is inverse tan. Inverse tan. And then you have V final X per dengan V final Y per V final X. Dah ada dalam lecture note. Okay, you can look from the lecture note. Okay, any question lagi before? Yes.
I have question. Kan
yes,
tadi Dr. mention.
Yeah, introduce yourself. Hadina, yes.
Hadina. Dia ada soalan sketching angle kan?
If.
if
Yes.
ada. So kalau sketch tu kita kena sketch just agak-agak je ke kena guna compasses?
Agak-agak. That's why the name is sketch. So kalau dia kata draw, you kena use the protector to have the actual value. Tak payahlah. Kalau the question is sketch, just sketch. You sketch angle berapa pun, you write down dekat situ 77. So the marker we know that that is the angle. So that's why between sketch and draw. Okay, boleh Hadina?
Okay, thank
Okay,
you.
thank you. Okay, we still have a time, so I open anything. So,
Doctor,
yes,
I'm Farhan.
yes,
Untuk yang equation H, untuk cari yang maximum height tu, H is
yes,
equal to V initial square sin square theta over 2G
yes,
tu.
yes.
V initial tu dia ambil kosong ke?
No, V initial lah.
Maksudnya dia at point highest peak tu, V initial tu ambil V mana?
At the highest point tu, this is kira V final. So bila dia kata V initial, V yang awal tadi for example this question kan yang tadi kita bagi 100. Tadi kan. Oh, ada soalan lagi satu lagi. Okay, for example kita bagi tadi 100. Yang ni lah. So mana V initial ni 100. So you kena guna this value lah. Maknanya V is mana V square sin theta V initial tu you guna this
guna
100
tu lah.
Yes. This is not zero. Zero tu is V final. Kalau ikutkan dia dah sampai dekat atas tu.
Maksudnya paling atas tu V final dah memang dah kosong.
Yes. Initial dia tak berubah. Dia memang start daripada sini. Initial is start from here. Okay, it's not involved. Okay, boleh try lah. Because tadi pun saya dah tunjuk contoh ni kan. You boleh kira sampai you dapat jawapan sama 299. That's why you tahulah which value that you can use. So saya nampak macam ada satu lagi last question. Saya pun tak ingat. Okay, I think senang je kot ni. Okay kan. A stone is thrown at the angle 30 degree above the horizontal from the top of the building with the initial speed of 50 meter per second. If the stone reach the ground in 6 seconds, what is the height of the building? Ini senang je ni. You dah kira dah? Berapa dapat? A, B, C, D. Anyone? Tak kira, cuba kira sekejap. Ini simple je ni. Dah ada nilai T, dah ada nilai V, initial, dah ada nilai angle. Masuk je dalam equation. Okay, so up angle 30 degree above the horizontal from the top of the building. Tak kisahlah daripada top kan. With the initial speed dah ada kat situ. So if the stone reach the ground in 6 seconds, what is the height? Dia nak dapatkan nilai S lah. So equation yang ada S dah ada nilai T. Satu je equation dia yang tu je lah kan. Kalau dia pakai V final, V initial tu dan soalan ni tak ada pun V final. Dia ada V final, dia ada the question is we have the initial V and then you have T. And then of course you have A. Satu je equation dia. Okay, cuba can you try first? Just A, B, C, D. We still have a time kan, kita baru dalam 10.30 baru. B. Okay, someone said B. Okay. Dah, okay dah tu kau. You kira dapat B lah nanti. Saya pun tak ada jalan kerja kat sini. So yes, you're supposed to have B. So you just masuk S. Kalau kau kat sini, you guna SY lah. Because dia nak tahu what is the height of the building. So you kena guna SY. You kena guna SX. Jangan guna SX. SX itu tak betul lah. So you guna SY equal to V initial T minus GT square. So but initial tu you kena guna sign lah. You have the 15, 15, sin 30. That says V initial. And then you darab dengan T, you darab dengan 6. And then you minus 1/2 G 9.81 and then 6 square. You dapatlah nilai B. Okay, settle. Dapat nilai B. Okay, any questions? Okay. So I think
Doktor,
at the end of, yes.
kan dekat yang lecture note tu, yang T tu dia represent apa?
Mana T mana satu ha?
Dekat kat nota.
Equation mana? Equation mana? T equal to apa?
T equals to 2V sin theta per G.
That time. Time for the total range. Okay, we have the equation R first kan. This is R equal to blah blah blah. This is the range from initial and to the final. parabola tu kan, initial final. This is the range. But the T is the time, is total. Okay. Tapi T tu sebenarnya sama je. Bila you kira T pada keadaan highest point, you darab 2 je lah. Because parabola tu dia symmetry kan. So you have the T at the maximum point, which sebenarnya sama je dengan belah sini pun. Okay.
Okay, thank you.
Welcome. Apa Isfahan. Okay. Okay, since we have so we in virtual, so maybe after this you kita tak akan jumpa lah kot. So because if you are in my tutorial class, so we meet again in the tutorial group. After this this is saya satu kan. I'm not sure you have the class or not in this evening or tomorrow. So after this, Dr. Samia will take over this lecture. Still in mechanics 1, but in the topic of Newton's law, if I'm not mistaken lah. So it's Newton's law, and then I'm not sure. You cover tomorrow and also the next week. Next week also she will be cover the lecture. Okay. So untuk tutorial, okay, for the tutorial that the question that I posed in Spectrum, so you need to solve. And then yes, I have I think 2 questions. Projectile motions, question number 5 or number 6. Okay, number 5 and number 6. So that the question from projectile motions. So after this class, you can try to solve, and then it will be discussed in the tutorial groups, tutorial class. Next week you have the tutorial class. So it depends who is your tutor or lecturer for that tutorial. So and then you will discuss on the tutorial, because some of you text me to ask the question, the solutions, and also to ask about that tutorial class, the tutorial material. But sorry, but I cannot I cannot give the answer and also the solution, because of it's not when you enter the tutorial class. So what do you expect? Because you already have the answer, you already have the solution. So baik tak payah masuk kelas kan. So that's why we have that tutorial class. You can discuss, you can ask anything with your tutor. So if you do not understand, maybe because kat sini kita ada checkbox. Okay, that's why it's good for the visual. This is ada have pro and con lah. So checkbox ni saya boleh baca satu-satu. So kalau face to face tak sempat saya nak baca soalan, tak sempat you nak bertanya sebenarnya, because of kadang-kadang because you disrupt my lecture bila you nak bertanya. So kalau dalam checkbox tak kisah, after the lecture saya boleh baca. Okay, so I think before we end, so apa lagi saya nak cakap, because I miss to ta'aruf with all of you, because in the face to face, so I will be ta'aruf first lah, because kalau nak start awal-awal saya takut the connection problem. So that's why I think still we have the time. So basically in tutorial group pun maybe you can be ta'aruf there. So if you, I don't know sure, because you have 254 students, so I don't know sure, maybe some of you is my junior, okay, in the school. So I'm from Terengganu, and then I'm from Marang. Can I have who from Terengganu? Can raise up your hand? I just want to know. Kita tak mengaku Terengganu pun tak apa pun. Okay, yeah. So I'm not sure, maybe some of you is my junior, because I'm from Marang and I'm from SMKA Durian Guling. But the problem is I cannot find any durian from my school, because the name is Durian Guling, but it's not any durian in my school. Okay, maybe some of you is my junior, but I do not know. Okay, it's good. Okay, so I think that's all. We already covered our lecture, 3 lectures, and then I already posted the tutorial questions, so you can ask them. And if you have any questions, okay, any question, you can chat me in the Microsoft team. Okay, but I'm suggesting Microsoft team lah, because some of you is too advanced. At 1 o'clock, 2 o'clock, still WhatsApp me. Okay, but it's okay lah. But I think 1 or 2 o'clock is not the time to disturb me lah. But I think for the Microsoft team, I think it's okay, because for the next day I will read and I will respond. Okay, so I think that's all for today. So see you again. Bye bye. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.